Hello everyone. Just let me know whether my voice is clear, audible, and my screen is visible to you or not. So on my screen currently there is a Google site. So just let me know whether it is visible and voice is clearly audible or not. Okay, thank you. We will just wait for a couple of more minutes and then we will start our today's practical session. Okay, so I think we shall start now. So today we will discuss how to perform AD practicals, basically the practicals of analog section, analog electronic section. That means practicals related to first 3 units on virtual labs. Okay. So what is actually virtual lab? So virtual lab is actually a platform which is designed by different IITs and ISC Bangalore. Okay. So they have created one platform on which there are multiple numbers of virtual labs are available. So now in today's lecture, we will see one of the similar virtual lab which is designed by IIT Kharagpur. Okay, so it is free to access. There is just internet connection is required. And I guess it is also accessible from mobile also. You can try it and let me know. Okay. So now for that, you have to follow some steps. So first thing is you have to open your browser and then you have to type virtual labs in that. Okay, so you can also type VLabs, virtual labs, that is nothing but VLabs. You have to type VLabs there. Okay, so you have to select first link. So you can just note this particular website www.vlab.co.in. Okay, just note this website. It is visible, right? My screen is visible. Okay, so then you have to go to the virtual labs. You have to click on this first link. Then this is the actual site vlab.co.in. So you can read about the virtual labs here on this site. This is home about us. Okay. It is an initiative of Ministry of Human Resource Development. So you can go through all these. What are the about us? You can read what are the objectives of these labs and all. You can find that. Then there are objectives, philosophy. So you just go through this particular website. There are you can observe. So these many institutes have participated and they have designed different virtual apps on this platform, on this website actually. We can observe IIT Madras, Amrita Vishwa Vidyapeeth, IIT Hyderabad, Triple IIT Hyderabad, IIT Kanpur, IIT Bombay. Okay, so these many institutes have designed a specific subject lab and they have formed, they uploaded it on this particular website, right? So you can see here that there are broad areas of these virtual labs. So you can select depending on which is your branch. So since your analog and digital electronics belongs to electronics and communication engineering branch, so you have to select electronics and communications lab. So I'm selecting this particular electronics and communication. Just remember the steps. First, we have opened our browser and we have typed VLab, and under the VLab, this is the home page of your VLab, right? Then we have gone to the electronics and communication. You can note these steps. We'll anyway forward the link on your WhatsApp group as well. Then in electronics and communication, there are different labs which are already ready to use. Okay, so you can observe these are the names of labs which are present, and this is the institute, name of institute that has designed this particular lab. So under this lab, this different list, you have to go to the basic electronics lab. In this particular session, we will discuss in basic electronics lab. So you can observe it is designed by IIT Kharagpur. There are different labs, okay? Electric circuits, signal systems. So we require this particularly. Whichever practical we are going to perform, analog part specifically, it is there in this basic electronics lab. So you have to click on basic electronics lab. Then you can observe window will appear. Now here you can observe there is introduction, list of experiments, instructions, technology used, people and feedback. So everything is mentioned here. You can also go through the introduction. The virtual labs project started as an initiative from Ministry of Human Resource and Development to create online interactive media which would help students learn difficult concepts in various domains. As a part of this initiative, the virtual laboratory for basic electronics has been developed. The objective of this lab is to perform experiments in basic electronic labs virtually. So since due to this pandemic situation, you have to perform the labs virtually only. Okay. So hence the basic electronics labs virtually, and 8 have close to real life experience. So this is very important that you should get the real life experience also. Okay. So as far as electronics concerned, we know that whatever the practicals or experiments we will be perform. So in real life, you have to mount the components and you have to take the readings like that. Okay, so same in this particular website or on this particular platform, main emphasis given on the real life experience. So the platform is focused on learning aspects as much as on performing the experiments. Again, these are a few key features of virtual labs. These are available 24/7. Okay, and students can learn difficult concepts at their own pace. There are many features of these virtual labs. So now straightly move towards the list of experiments. You have to click on list of experiments. So under this, you can observe there are total 1, 2, 3, 4, up to 17 experiments are there. But as far as we are concerned, from this list, we will discuss experiment number 10. Okay. So you can note it down. We will perform only 2 labs under this particular virtual lab. That is, first one is BJT common emitter characteristics. It is lab number 10. Okay, so you can note it down. Under basic electronics virtual labs prepared by IIT Kharagpur, the first experiment we will see common emitter characteristics. We have already discussed this earlier session, right? What are input characteristics, output characteristics, and so on. Okay. So this one we will see practical number 10. Okay. So this is serial number 10, BJT common emitter characteristics. Right. And then one more from this list we will see, that is number 16. Okay. So number 16 is study of basic properties of operational amplifier, inverting and non-inverting amplifiers. So we have already seen these inverting and non-inverting amplifiers using op-amp. Okay. So these two, that is serial number 10 and number 16. These two we'll try to perform in today's session. Okay. Then I will first visit this particular experiment, that is study of basic properties of operational amplifier. non-inverting and inverting amplifier. So I am clicking on that. All right. So here you can observe in virtual labs, at the home page, what you have done, you have gone through the basic electronics lab. Then under basic electronics lab, you have gone, now you are in the study of basic properties of operational amplifier, inverting and non-inverting amplifiers. Okay. So these are different tabs which are present here: theory, procedure, simulation, quiz, assignment, and references. Okay. So you can refer all of these, but importantly, you should know the theory. Of course, we know the theory, and then you have to follow this procedure while doing this simulation. This is very important. Okay. Now our procedure will be somewhat different than this procedure. Okay. So while performing virtual labs, you have to follow this procedure only, right? So this procedure you have to follow, then simulation. So under theory, you can see there are the objectives. What are the objectives of this particular lab? So at the end of this experiment, students would be able to explain what is inverting amplifier, explain non-inverting amplifier, and explain what is gain. Okay, so these are the objectives of this lab, that after this particular lab you should be able to understand these concepts. uh, Theory is also given here, you can go through this. Okay, I will cover only practical aspect of that. You can go through this theory, we have already discussed it in theory class. So inverting amplifier and some formulas related to inverting amplifier. You can observe this is nothing but output. This is the formula for gain, right? V out divided by V in. V out divided by V in is nothing but closed loop gain. So this minus sign will be here. So minus Rf upon Rv, R in. Okay. So similarly, V out can be calculated from that formula as well. You have to take V in, which was in the denominator. It has been taken on the other side, and then you have to do this multiplication to get V. So mathematical portion is also covered. Then simply about the non-inverting op-amp, the information is also given here along with the gain formula. Okay, so this is the gain formula for non-inverting amplifier, 1 plus Rf upon R2. Now suppose they have taken R2 in place of power. Okay. So in our theory class, we have taken it as R1. So there is no problem. So this is regarding the theory. You can go through the then the procedure. So in order to perform the simulation, you should follow these steps. Okay, so it is explained in is here explained. It is explained very nicely. Okay, so let us go through. I'm just reading it for you. Let us go through the experiment of inverting amplifier. So this is the procedure for the inverting amplifier. Okay, this is procedure for inverting amplifier. Now you have to do the connection as per here. This connection. Okay, so we will see in simulation. So you have to do this connection. Okay, so for that you should be able to first know what is the circuit diagram of inverting amplifier. Once you know the circuit diagram of inverting amplifier, then you can observe here, this is inverting terminal, this is non-inverting terminal. Since it is inverting amplifier, non-inverting is grounded, and input V in is given to the inverting terminal. Okay, so RF is your feedback resistor, R1 is this resistor. You have to do corresponding connections, and you have to follow these steps. Okay. Similarly, the procedure for non-inverting amplifier is also given along with the connections. These are the connections of non-inverting amplifier. You can observe this is non-inverting, and now V in is given to the non-inverting, whereas inverting terminal is grounded. Okay, so just go through these connections. I will straightly move towards the simulation. So these are pretty straightforward procedure. Now the next is simulation part. So before going to the simulation, is it clear up till this point? If you're having any doubt, then you can ask me. Okay. I will again one more time. I will follow the steps from starting so that those who joined later, they will be able to understand. Okay. Again, first step is you have to open your browser. You have to type VLabs there, that is virtual labs, and you have to select the first link. It is www.vlab.co.in. Okay, so this is the home page of virtual labs. So these labs are designed by the different IIT. Now under this, so these are the participating institutes, and these many labs. There are various labs which are classified under these broad areas. So since we are discussing analog and digital electronics, so we need to select this electronics and communication area. So under this again, we have selected basic electronics lab. Okay, so this is basic electronics lab. It is designed by IIT Kharagpur. Okay, so I have selected that. You can just go to the list of experiments. So under that list, in today's session, we will discuss uh, experiment number 10, that is BJT, common emitter characteristics, and number 16 as well, that is inverting and non-inverting amplifier. So I'm selecting inverting and non-inverting amplifier first. Here you can observe under this lab, there are, under this experiment actually, there are different tabs: theory, procedure, simulation, quiz, assignment, and references. Okay, so theory, you can go through the theory. Theory is given, then you have to follow the procedure. Okay, you have to follow this procedure. Now we will straightly move towards the simulation. So now this is the simulation window. Okay, so now you can observe there are two tabs again. First one is for inverting op-amp and second one is for non-inverting op-amp. So now let's select first inverting op-amp. Okay, so I am again clicking to the inverting op-amp. So as soon as I click towards inverting op-amp, you can observe one window will appear. Okay, so this circuit is discrete, that means it is not connected. It is not a complete circuit. There is no connection between 2 points, right? So what you have to do, you have to connect the circuit first. Okay, and then by these many parameters you can vary. You can vary three parameters: input voltage, R1 resistance. The value of R1 resistance can be varied by varying this. Okay, similarly feedback resistor RF can be varied from here. So three controls are given there: input voltage, resistor R1, and resistor RF. Okay, so again you can also check your connections, you can delete your connections. So first we will see what are the connections. So how to connect this circuit is already mentioned in procedure. Okay, so I'm just trying to connect it. So I know since it is inverting op-amp, So you have to just connect this point. You have to just select this point, and one wire will appear automatically, and I am connecting it to the ground. Okay. So since it is inverting, non-inverting will be grounded. We know that. Now this is feedback resistor, so we know it will be connected between output. I'm just clicking on that particular pin and one wire will appear. So you can observe it is very easy. From here again you have to connect it to here. Now these two terminals also you have to connect. Right. Now this is input voltage. So input voltage should be given to this. Now you can observe this, our circuit is now complete. So if you observe, input is given to the inverting via R1, Vin is given to the inverting terminal via R1, and feedback resistor is connected between input and output. Okay. So if you are having any doubt in this connection, then you can also check. You have to click on check the connection. So you can observe here. Okay, so one window will appear. It shows the right connection. Set resistance R1 and feedback resistance RF and input voltage. So the connection is right. Okay. So what this window said, it instructs you that your connections are right. Now you have to set the different values of R1, RF and input voltage. Okay. So we'll say okay, we'll do that. Then from here you can observe first input. Now Vin I am considering it as, let's say, you can vary, and corresponding value you can observe here. The corresponding value is displayed here. Just observe this particular field, right? You can observe I am varying this and it is the values are varying. So I am keeping my input voltage as let's say I will keep it as 5 volt. So this input voltage is nothing but 5 volt I have kept, right? Then next is resistance R1. Where is resistance R1? It is here. It is the value of resistance R1. Okay. So this was your V in, this is resistance R1. Okay. So now we will select the value of resistance R1 and we will select it as so this R1, if you observe, it is in kilo ohms. So unit is also mentioned here. Both resistances are in kilo ohms. So I will keep it at 10 kilo ohm. And then finally RF. So RF is nothing but I will keep this value as 20 kilo ohm. Here it is RF. Okay. So all these three values we have set. Input voltage is 5 volt, R1 is 10 kilo ohm, and RF is 20 kilo ohm. Now tell me, what is the formula for the gain of inverting op amp? Can anyone tell me? What is the formula for the gain of inverting op amp?
1 plus RF upon Rin.
Anyone? It is actually for non-inverting. What you have said, the formula is right, but it is for non-inverting op amp.
Minus RF upon Rin.
Right. So for inverting op amp, it is minus RF upon Re. Okay. So what should be in this case? What should be the gain? Where RF is 20 and R1 is or Rin is 10. So minus RF upon Rin, that means minus 2 should be gain, right? Minus 2 should be gain. That means your output should be minus 2 times your V in. Gain times आपका जितना gain है उतना आपका input will be amplified at the output. So here the gain is minus 2 and input is 5 volt. So your output will be 5 multiplied by minus 2, that is minus 10. So when you have selected this particular parameters, then you have to simply go to this tab and you have to click on add to the table. So this is the table actually. So I am clicking on add to table. So here you can observe okay, so something is not correct here. Input voltage 5 and output voltage is showing minus 85. Went wrong. Okay, we'll take another example and try to find out. R1 again I'm keeping it as 12. RF is let's say 36. Right. Okay, now second entry is correct. Okay, so just observe this second entry. The input is minus 2 volt. This is my input, minus 2 volt. RF, the value of RF was 36. Okay, so this now gain becomes minus 3. This is also wrong. What is happening? We'll again make connection one more time and then we will see. Okay, so inverting the PAM. All right. Now I'm doing connections one more time. You can check the connection, the right connections. Then you have to select input. I have selected 2. R1 let's say 5 kilo ohm. And RF let's say 10 kilo ohm. Okay. I added it to table. Okay. Right. Okay. So now our entry is correct. So now our input voltage we have applied it as 4 volt. Okay. RF is 10 ohm and R1 is 5 ohm. So what will be the gain of this inverting amplifier? Minus RF upon R1. That means minus 10 upon 5. That means minus 2. And what will be the output? The output will be minus 2, that is gain multiplied by input voltage. Minus multiplied by 4, that is minus 8. Okay, input voltage is 4, output voltage is minus 8. So this current you can neglect. There is no need of this particular current. Okay, so you have to just observe these two entries. Input voltage जब आपका 4 volt था, your output was amplified to 8 volt, but since it is inverting, minus sign will be there. Okay, I'm again changing the value from 4 to, let's say, 6 for 6 input. Now the circuit gain is minus 2. So 6 multiplied by minus 2, minus 12 should appear here in the next. So what you have to do, you have to go to the add to table. So this reading will be automatically saved to the table. Okay, you can observe this is your third. When input is 6 volt, your output is minus 12 volt. Okay, again you can vary this input. I'm taking it, my input is suppose 10 volt. So what should be my output when input is 10 volt? Anyone? When input minus 20, right? So I'm again going to the add to table. You can observe here again the entry has been added. For input voltage of 10 volt, I'm getting 20 volt, right? And you can take as many readings you want. For 12 volt, it is minus 40. Okay. From this particular one tab is there, plot. So by clicking on plot, you can also plot this. You can observe this is the plot. So initial our reading was incorrect. This one was not correct. So you have to skip this part, and these correct readings are, you can observe by observing this reading, you will see that you are getting linear line, linear relationship between input voltage, linear relationship between input voltage and output voltage. Okay, so hence we have seen this if you remember, we have seen that inverting amplifier, non-inverting amplifier, these are linear applications of op amp. Why linear applications? Because the linear input voltage and output voltage are in linear relationship. Okay, now if you want to take this particular plot, then you can also take the print of it. Okay, I'm just taking the print of all the plot and readings, and I am saving it. So let's say I'm saving it. Now I'm again going back to the downloaded. So here you can observe it is visible, right? One document will be generated like this. So here your circuit will be also, your connection is also visible, and different readings which you have taken, it is also visible. So our first reading was not correct. Okay, so it's all right, don't worry about it. And again V out and V in plot is also there. So in this way you can perform. Okay, this PDF is generated. In this way you can perform your practical. Okay, I will just wait here for a couple of minutes, and you can, if you're having any problem, you can ask me. Okay, so I got one question that how to save PDF to device. So I'm again doing that process. Okay, so I'm again. Okay. So once it is up to this point, I think it is understood to you. So once you have taken all the readings, you can also plot, right? You can also plot it. And here is one icon is given, that is print. I hope it is visible to you. So you have to click on this print. When you print it, then it will be automatically ask you to save this particular PDF file. You have to simply save it. Is it fine? So since I am operating it on PC, these are the steps in PC, right? You can just observe whether it is possible. I have already done it in my mobile also. So from mobile also it is working fine. So you can just check it whether it is possible with mobile or not. But it is certainly possible with PC, your laptop. Okay. So I will again discuss this complete one more lab we will take, that is of non-inverting operational amplifier. It is exactly similar. Now I am closing it. Okay, so under the same experiment, if possible, you can take the PDF, you can generate the PDF. Now we are just trying whether it is possible or not. So this is the way to do it. We'll see what are the different problems which we'll discuss it later. Okay. So again, the next thing is non-inverting amplifier. Again, we have already completed the inverting portion. There is non-inverting amplifier. So I have clicked on that. Again, one window will appear. This is experiment table. You can observe these are experimental table. Again, instruction from by going to this instruction, you can instructions are already there. How to connect, right? You have to just go to the instruction, and the instructions will be there. Now again, these are different components, but these are not connected. So you need to connect it first. Okay. Then again, same controls are given: input voltage, resistance R1 and RF. For non-inverting operational amplifier, the formula for gain, that is formula for V out divided by V in, is 1 plus RF upon R1. Right. So now you have to do the connections first. You have to do the connections now. So here it is V in, okay, and this is ground. So since it is inverting, or sorry, it is non-inverting, so V in should be given to the non-inverting input, and this is feedback. So we know that feedback resistance is connected to output, and another one is connected to R1. This terminal is also connected to R1, and since this is inverting terminal, inverting is grounded. Why? Because it is non-inverting op-amp. So I have done the connections. You can also follow the instructions. There are the connection, how to do the connections. It is already mentioned here. Now I am checking whether my connections are correct or wrong. So when I click the check connection box here, one window will be generated saying right connections. So set Next instruction is you have to set R1 feedback resistance RF and input voltage. So we'll say yes, we'll do that. Now you have to select R1. So let's say R1 is 10 kilo ohm. I have taken as R1 is 10 kilo ohm. Then RF I am keeping it as 20 kilo ohm, and input voltage, input is here. Okay, so input will be displayed here. So input I am keeping it as, let's say, 3 volt. So input is 3 volt, R1 is 10 and RF is 20. Okay, now you have to add this reading to the table. So I am keeping on add to table. So here you can observe input voltage was 3 volt. For 3 volt for 3 voltage of input, I am getting output voltage equals to 9. Right? That means the gain is 3 times. So the gain is nothing but 3. But we know that what is the formula for gain? 1 plus RF upon Rin. So the value of RF is 20 and the value of Rin is 10. So RF upon R1 is 2. 20 divided by 10. Okay, 20 divided by 10 is 2 and 1 plus 2 is 3. Okay, so the gain of this circuit is 3. Hence, when input voltage is 3 volt, the output is 9 volt. Okay, so now you can keep this gain constant and just vary the input voltage. Now I have taken input voltage as 4 volt. Now again I have to add this to the table. You can observe for 4 input voltage, your output is 12. 4 multiplied by 3. Similarly, you can take different readings. For 5 it is 15. For 7 it is 21. For 10 it is 30. Okay. Now once you have taken enough readings, then you can plot that readings. So now you can observe this is the plot of input voltage and Vout voltage. So earlier plot, if you have observed, it was decline line having negative slope because that was inverting amplifier. But here you can observe the slope is increasing, and again the line is linear. So this is also non-inverting amplifier. It is also a linear application of op-amp because output inputs are in linear relation. Okay, so now again you can take print from this icon. You have to click on this icon. So document here, it will be saved in the form of PDF. So non-inverting operation amplifier, I am saving it here. And again going to the downloaded document. Here you can observe this is the downloaded document. So these are our readings. Don't worry about the current. Okay. The circuit diagram is also there and plot is also you can observe. So in this way, this is actually very simple, inverting, non-inverting. So all of you should try to complete this practical. I hope it is clear to you. Anyway, if you are having any difficulty, then you can ask me right away. So this particular experiment, that is experiment of in basic electronics lab, experiment number 16. Okay, so we have seen this study of basic properties of operational amplifier, inverting and non-inverting amplifier. Okay, so then again simulation we have done. You can there is also quiz. So if you go into this quiz, you can also test your knowledge, right? So shall we go for the quiz? Okay, you need to give the answer. Okay, so I'm starting this quiz. This quiz. I guess the quiz is not okay. It cannot be accessed, right? So it's fine. Then in assignment, then there is nothing. Reference, nothing. Okay. So quiz, assignment, and references are, I think they are not updated. Anyway, these three icons are important to you: theory, procedure, and simulations. So just let me know whether it is clear to you how to access this lab and how to perform the practical of inverting and non-inverting amplifier. Just give me your feedback whether you have understood it or not. Okay, so those who have understood it, then they can perform. Okay, after this particular session gets over, and you can also submit the PDF which is generated. Just rename your PDF with your roll number. Okay, two PDF will be generated. One is non-inverting and another one is inverting. So keep that inverting non-inverting amplifier as it is, and write your roll number. That rename it with your roll number. For example, if your roll number is 20, then 20 inverting amplifier, 20 non-inverting amplifier. You have to rename like that, and you can send it to me on WhatsApp, or you can also mail it. Right, very good. So one student have already understood, and she has also performed it. Okay, you can forward it on my WhatsApp also. There is no problem. And those who are facing a problem, they can also contact me. Okay. So similarly, you can just try. Okay, I'm not asking you to do it, but similarly, you can just try for the experiment number 10. That is BJT common emitter characteristics. So again, I'm going to the BJT common emitter characteristics. Here also you can observe theory is given, so you can go through the theory. I have already explained it in the last session, but that explanation was according to our manual. But here, if you want to do this correctly, you have to follow these procedures. So when you go to the procedure, you can observe again input characteristics is first part. So your this connection is already done. You have to just follow these steps. Okay. Similarly, for output characteristics, again the steps are clearly indicated. You have to follow these steps, and when you do that, you will be able to. So again, in simulation, there are two tabs: BJT input characteristics, BJT output characteristics. Okay. In BJT input let's say we have selected BJT input characteristics. So now you can you are understood how to access the virtual labs, right? So now you can do that. Procedure is already mentioned there. You have to just read the procedure carefully and follow the procedure. So again, so this is your input characteristics. So we have seen that input characteristics is nothing but the graph between input current and input voltage, and output characteristics is nothing but the graph between output voltage and output current. But what you have to make sure is the instructions also. If you are having any problem, then you can just simply go to this instruction tab. You can read what is the first instruction. Initially set rheostat RH1. Where is rheostat RH1? And rheostat RH2 at 1 ohm. So here you can observe two controls are given to you, rheostat RH1 and rheostat RH2. Now observe what is happening here. So whenever I am varying this RH1, you can observe the input characteristics or the input readings are varying. I hope it is visible. Varying this knob, the output characteristics are varying. Okay. So what you have to do, you have to again first here you can observe it is said that make the collector emitter voltage constant. While discussing input characteristics, I have told you that whenever you are working on input characteristics, the output parameter, that is collector to emitter voltage, should be constant. So now this is collector to emitter voltage. This is output current IC. It is input current IB. So just let me. I hope now it is visible. This is your collector current. This one is the indicator for collector emitter voltage. Collector to emitter voltage. This one is base to emitter voltage, and this one is base current. Okay. So now whenever you are doing input characteristics, you have to make this VC constant. So we'll keep this VC at 1 volt. So you have to in order to vary this to 1 volt, you have to vary this knob. Only two knobs you can vary. Okay. So just observe, I am varying this and I am keeping VC equal to 1 volt. So here you can observe VC, I have kept it as 1 volt. Right. Now don't vary this second. Now this second control should be kept constant, because first control is nothing but to vary these input readings, and second control is for varying output readings. Once you have kept VC constant at 1 volt, don't vary this knob now, RH2, that is rheostat 2. Okay. Okay, so just 1 second. I will connect the charger. Okay. So now we have made VC constant. Okay, you can observe here it is constant at 1 volt. Now we will vary only this knob, that is RH1. Okay, so you can observe by varying this knob you can take the different readings. So I am varying the value of VB. Okay, so first I will be keeping VB on 0. Let's say 1. So it is 0.1. Now I have to note this reading. So what you have to do, you have to add to it table. Now as soon as I have clicked on add to table, you can observe collector to emitter voltage is set to 1 volt and the corresponding reading of VB is also mentioned here, and the current, base current, it is also mentioned here. But remember, the base current is in microampere. Okay, the unit is microampere. Similarly, you have to vary first knob only. Now I am varying this column actually and observing this current. So for 0.1 voltage of VB, this is the current. Now I am varying this in uniform step. So 0.1 के बाद I will select it as 0.2. Okay, so I am selecting it as point. Okay, so 0.3 I have selected. So again you have to add, you have to click on add to table in order to record this reading. Again 0.3, the reading has been recorded. Again you have to vary rheostat. Let's go with the 0.5. Anyway, 0.52, let's say. So again I am recording this reading. Again vary this. I am varying at random. Okay, so I will just take few readings at random. You have to just vary that knob and click on the add to table. Okay, so I'm just varying that knob and pressing on, clicking on add to table. So these many readings I have taken 9, and we just last reading is, let's say, 10. You can keep uniform steps also here. Okay, but now I have taken it in random steps. So now once you have sufficient readings, now next is you have to draw the plot. If you observe, input current is nothing but base current and input voltage is this voltage, base emitter voltage. So now you have to okay, so in order to generate the plot you have to click on this tab, that is plot, right? So I have clicked on the plot, so you can observe this is exponentially increasing graph. It is exponentially increasing graph. Now again I can take the print of the same from here. Okay, so again print, I am saving this print as a PDF already. I have saved it. Now I am again going to download section. So it is saved by the name BJT C input characteristics. Okay, so you can observe this kind of PDF is getting generated. So this is the plot, right? So in this way you can also perform output characteristics. So everything is mentioned clearly actually in the procedure itself. So you don't worry about it. You have to just go through the procedure and follow the instructions. Then you can perform the practical. Okay, so again you can do this. You can just try. If you're having any problem, then you can perform it later over. So this is regarding the BJT common emitter characteristic. Again, let me check whether the quiz is accessible. Start. Here quiz is working. Okay. So now first question is identify the, okay, you can observe, identify the terminals on this BJT and also type BJT NPN or PNP. So you can go through this particular quiz as well. There are 5 questions. Okay, you can also go through that. In references, so references are also given. So you can observe few books are mentioned. Robert Boyle's read. So it is a quite nice book. It's a, then you can observe, if you have not understood this concept, then you can also go to the video lectures. I will just see whether it is working or not. So I am going to the first NPTEL note of bipolar transistor. So I hope you all know what is NPTEL. Okay. So there are many videos taught by IIT professors. These are already combined on the NPTEL platform. So it stands for National Program for Technical Education Enhanced Learning. Technical Education Learning. You see that. Okay. So after clicking on that, NPTEL, this window is generated. Okay. It is also available on YouTube also. You have to just type your subject name, and after that, suppose you have to type ADE, so Analog and Digital Electronics NPTEL lectures. Just type this on the YouTube, and you will observe few lecture series. Okay, so these lectures are given by the IIT professors. You can also go through them. All right. So anyway, so I am again summing up this today's practical session now. So what we have seen in this today's practical, we have seen 2 labs, virtual labs. We have seen how to access the virtual labs. Okay, so first you have to open the browser, then you have to VLab. V stands for virtual lab. Then you have to select the first link, vlab.co.in. Under that, you have to select the broad area of electronics and communication. Again, under that, I guess computer science is also there. Okay, so computer science and engineering is also there. You can also visit that. Lots of labs are already available. Okay, so just go through them. We have gone to the electronics and communication. Then we have selected one lab which was by IIT Kharagpur. The name of lab was Basic Electronics. So under that Basic Electronics lab, again we have gone through the list of experiments, and only 2 experiments are of our use as per our syllabus. First one is 10th, that is BJT common emitter characteristics, and then 16th, that is inverting and non-inverting amplifiers. Okay. No. Okay. So the question is, I have one query that Moodle नाही करायचा आहे का upload. So basically, the Moodle cannot be integrated with the ADE labs. Okay. जैसे आप बाकी के कोर्सेस में कर रहे हो एक्चुअली, जैसे जावा या फिर ओप्स में वगैरह आप कर रहे हैं, तो फ्रॉम Moodle itself you are doing that, right? But here it is not possible because there is programming, so that's why it is possible. Okay, so for our course it is not possible to perform practical from Moodle. That's why we have gone through this particular way of learning. Okay, is it fine? So PDF you can submit it until the next lab session. So until next week, okay? Don't worry about it. And just also let me know whether it is accessible from mobile or not, or whichever problem you are facing, just you can contact to me. Okay, so just try these two labs, follow the procedure, go through the theory, and it will be a nice experience for you guys. Okay, so that's it for today's session. We will conclude our session here now. If you are having any problem, then you can ask me. Otherwise, you can. Thank you.